Hello, bonjour. Welcome to another class of PETR 2135 or Production Engineering. Today we'll cover a very important part of the whole process is the field life cycle, which will actually give like the overall of the course. I'll just recurring the whole ideas again back to you, and then we'll actually cover field appraisal. Okay, so before starting the lecture, let's actually learn some terminologies like the prime contractor. So prime contractor, the oil companies which in the controlling interest in an operation, and NOC are like the national oil companies. Okay, so national oil companies means it's company owned by a government body. Okay, so we already have seen this diagram, but let's explain again. So in the whole petroleum industries, we have three major measures areas or sectors. First, the upstream, which actually deals with the exploration, appraisal activities, and also the production. Then it goes to midstream. Midstream is mostly consist of the part of field processing, okay, field pipeline gathering, pipeline or any type of transportation, like transmission pipeline or any type of transportation that also would involve like storage into, which is a very big part. So that's the midstream, and the downstream is mostly the processing and the distribution part. Okay, so the processing means like the processing of the petrochemical, like manufacturing. For instance, if it's oil, that's the refinery we're talking about, and if it's the gas, then it would be natural gas processing field. So after that it goes to the end user. So this is about like the whole downstream actually sector works. Okay, so these are the differences. Now in case of field life cycle, so what is the overall picture of oil and gas field or like a reservoir? Okay, so what is the overall picture of the reservoir? So it is mostly the upstream, right? The field life cycle, we're actually talking about like the upstream field life cycle. Okay, so the first part is gaining access. We have learned how we do that, right? It reserves to the who actually holds the mineral rights, right? So that after that goes for the exploration, and then the field appraisal. It whether we should go for the appraisal or not, we'll actually learn a lot about this in our class today. Then the field development, the production, and after the production has been done, we do the decommissioning. Okay, so during that part of the development, production, and decommissioning, there are lots of environmental issues comes in, like the and also the exploration too. So like at the decommissioning, we do the EIA. Before even like do the development, we do the EIA, and before the decommissioning also, we do the EIA, so that we can safely install the the units and start the production and do the operations, and also if we can safely decommission the the field or abandon the field. Okay, so the cycle could be sequential or could not be. We'll actually see. Sometimes what's happened, we do the exploration and we start doing the development and appraisal together, okay, parallelly. Or sometimes we do the appraisal in the middle also, like I mean at the end of the development. It all depends, all right. It all depends on the situation. So it's actually and sometimes we even do not do the appraisal at all. Okay, so this that happens. And the development and decommissioning also, for instance, right after the exploration, we can start the production, and we can just so it totally depends on what is the situation we actually have, and we will actually learn today about different situations and what is the right step we should actually have to take. So the next slide will give you more idea on how the whole field life cycle actually works. And as you know, like I mean everything actually should have an equivalent, a base measurement for taking the decision. So here is the base measurement is the cash flow. Okay, that means based on the cash flow, we'll actually say how the field life cycle actually works. Okay, so let's see that, and then we can have a better idea. So this is the picture of the field life cycle and the typical cumulative cash flow we actually look in here. Okay, so the first part of here at the y-axis, you can see like the cash flow in million. Okay, sorry, cash flow in million. And here at the x-axis we have the progression. Okay, so the progression of like the time, progression time, okay, in year. All right, now as you can see here at this picture, like the negative curve, that means you are actually investing the money. Okay, so the cash flow, that means that it's the negative balance, that means you are investing, it's the investment, and after the investment you will get the return sometime. Okay, so from t equal to 0, at this time you gain the access, you lose some money because you have to pay some fees and stuff at the at this point, and you do the exploration activities again, you lose some, you are investing. Okay, then you if you actually go for the field appraisal again, you invest the money. So these are the timelines. So like right now at 2020, you start working. So after like 1 or 2 years, you can gain the access. Okay, it's a heavy paperwork, and the exploration activity also take a couple of years, and then the price you can actually if you can actually shorten the time, that means the investment would be less. Okay, now after that, if you do the appraisal and then you find like the very positive thing, yes, the exploration results give a good indication, like the field has a huge deposit, and the appraisal also give us a better decision, like yes, we should actually start go on, like it's a green signal. Then you start investing the major chunk at the development. As you can see, like it's just a comparative showing, but as you can see, just right before the appraisal, you have invested like less than 200 millions of dollars, right? But in the time of the development, as you can see here, you are investing something like nearly 500 millions of dollars. It's like nearly 300 billions or even more actually do the invest for the development purpose. And once you start doing the development, and then what? Then you start doing the production. Okay, so here you can see, like, I mean, it's some it's a small part here. This is because we actually do some test purpose. Okay, so like, I mean, kind of like, I mean, pilot, right? Like, I mean, not like the selling the or like, I mean, producing constantly. It's just things. So so basically from here you can see, like, okay, we have started doing our production now. Here it is, for instance, this is the curve of the production. So it can be like this, or it can be even sometimes like this, or it can be even sometimes like this. It all depends on the type of reservoirs we are actually using. Okay, now based on this development of the production scheme, production chart, our cash flow will start being positive. Okay, as you can see in here. Why? Because the more we get the production, the more we actually earning money. We're selling the product and earning money, right? So as you can see, I mean, it took nearly like 9 years from now. Like, I mean, if you start right now, okay, if you start just right now, for a reserve, it will take 9 years to get the first product. Okay, so it's just an average. It can be more or it can be less. It's just the average. Okay, so nearly it's like the 9 years to get the money back. I mean, to start getting the money back. Okay, and as you can see, once it starts, it's all, I mean, you have a small amount of operational expenses, but what I'm actually showing in here is the cumulative cash flow. So that means, like, these expenses have already been substituted, and that means you are actually having this curve. Okay, that means you are actually earning the money. Okay, so from that time it will take like 3 or 4 years, okay, to get the cutoff. Okay, so what is this point? This point is the critical point that you actually reach like the zero. So there is no loss or no gain, kind of like that. Okay, and beyond that, it's all the profit actually you're gaining. Okay, now as you can see, like, I mean, the more the production you will have, the more profit you'll gain. Okay, so if a field's life cycle, I mean, total life cycle is like for 25 years. So when you do the production, and then it would start decline one time. Okay, I mean, it's the natural, it will start declining. I mean, if you use enhanced oil recovery system, as we have learned before, and many other different techniques, so then maybe you can actually make the curve looks like this, what I have drawn. Okay, but still there is a declining period, and that's exactly why you will see, like, here at this point there is a sharp steep amount of money is coming down, right? So what is your profit? Your profit would be, your net profit would be this. Okay, so, like, I mean, this amount of money you will have from this whole operation. And also you got to remember, like, I mean, for the decommissioning we also need to invest some money. Okay, so in decommissioning also we probably need to invest some money. So I mean, this should be the real curve we'll actually have. All right, clear? So this is how the cash flow in the field life cycle it actually works. So as we said, like, these are the steps, and there's some, I mean, explanation, like, I mean, what are the steps. For instance, like, I mean, how you gain access, we already have explained that. So these are the NOCs as we are explained. So for instance, like the Petrobras is for Brazil, ONGC is for China. Sorry, ONGC for India, CNPC for China, and Saudi Aramco for Saudi Arabia, and the Russian one is Gazprom. Gazprom is the Russian. So there are many NOCs actually in here. So mineral rights, you already know what are the differences, and from US and Canada, we have gone through every of these, and gaining access, we know. Exploration, we have explained a lot about the explorations in the previous chapters, right? So the first stage could be like the visual cues, or like to look at the SIPs, and then we do the preliminary surveys, like a gravity survey, for instance, or electric survey, and then we'll go for more in-depth, like a seismic survey or 3D seismic survey. And then we can actually go for the wildcatting. That means like hit or miss types, right? So this is visual cues. Okay, so there's it shows like the Beverly Hillbillies in 70s, and there's a movie, I guess, in 90s. And so there's a family all of a sudden became the tycoon, and then they moved in LA in a very, from like the countryside, like the village, they all of a sudden moved in big cities. So it's about like that movie. It's a funny movie. If you can watch it, it's fun. So anyways, so this is the visual cues, the exploration. We know how to do the explorations. So yeah, you can watch these videos again and give us a thought. Okay, seismic survey, we all know about these parts from our previous slides. Okay, now appraisal. Appraisal, what is the objective of the appraisal? So appraisal, to perform it, performing the appraisal activities on discovered oil and gas accumulation is to reduce the uncertainty. Okay, that means we do the exploration. Actually, we do the exploration part to reduce the uncertainty of like whether we should explore in this area to find oil and gas or not. Okay, now the appraisal is actually to, in plain words, to analyze the data, like the seismic data or any type of data, for instance oil logs data, any other activities, to invest more money in this part, like to data analysis and stuff, and then to reduce uncertainty about the oil and to become more sure, like how to provide more information, like what type of decision we should actually take at the next action. For instance, how big would be the production, or like the process facility would be, how big would be the pipeline, how large and big would be the supply chain. Okay, how big would be the crew, like the everything. So for in plain words, it is like how much money should I actually invest. You see in here, you remember this curve. At this point we just invest more and more money for the development, like the maximum money we actually put for the development. This appraisal actually gave us more idea, like how much money we should invest more for the development. That means if you do the appraisal and if it gives you like okay, so there's not much oil you will find in here. So probably you will find, your development, if you only install like, small small facility, that would be fine. That would not be like, oversized. Then you can actually save some money. So just go for it. That means if you do this appraisal, so probably there is a probability that you can actually save some money. Or it can also save you some money from potential loss. How? You just have a guess, like, from the estimations, from the geologist estimation, like the preliminary estimations, said like, okay, so probably we'll get 20 billions of barrel of oil in here. Then you set up your all these logistics and the equipment, like processing facilities, everything based on that. And when you actually start drilling, and when you actually really did that, after that you will find like, oh, it is really inadequate. We can actually this actual oil can actually produce 100 millions of barrels. So in that case, what you can do, either you can you already have invested the money, okay, so you can invest even more and make a second facility, and that's actually more expensive. But so that's more like, making an undersized supply chain, production, process facilities, and etc. So the appraisal actually gives you like, these types of idea, or it will also give you ideas. Should you stop the activities or sell the prospect? Like, when would you actually stop the activities? You would stop the activities like, okay, probably there would be no the oil and gas, what we actually find in here is very inadequate, and we will not go after that. So that is like, stopping the activities. And when you sell the prospect, for instance, it's totally out of your scope, then probably you would sell the prospect to other companies, okay. And the next action also could be undertaking more appraisal, like, okay, so it gives some indication, like our first estimation, we actually call it gestimation, guess plus estimation, gestimation, okay. So it's like gestimation, guess plus estimation. So our first gestimation was like, okay, probably we'll get like, our initial gestimation was like, 20 billions of barrels, but when I did the appraisal, it became 30. So if we can do a little bit more data analysis and more appraisal, then probably we'll have some figure, like, there's a probability like it could be 30 or like 40, in between something. So if you actually want some more better confident on our data, like, we want to make sure, like, is it really 30 million, or we got like up to 40, or we'll get more than 40. So we need to do more appraisal, that means more data analysis rigorously. So that kind of step we also can take. Or like, okay, it can also give us a green signal, okay. So like this, red lights, right? So stop or sell activities to undertake more appraisal, or yeah, just go ahead. Our estimation, and if the data looks good, so go ahead. So these types of ideas actually we'll get from the appraisal, okay. So these are the things actually we have discussed already. Field development, and we'll actually the later slides will go even more further. So development, the development phase involves the creation of the development plans, okay. That includes the drilling that requires production and injection of the wells, preparing surface infrastructure, planning and preparing the pipeline storage to move the capture the hydrocarbons, and installing and upgrade the facilities or gaining access to the existing infrastructure, and even more, okay. So these are the part of the field development, which is one of the highest investment the companies actually do, or the operators do, okay. Then The next stage is the production, and the production phase it begins when the first commercial quantity of oil and gas are produced for the market. So remember the first commercial quantities. Okay, so before the production, we also have some type of what do you say? It's like pilot type. Okay, but the first commercial quantities of oil and gas, the project can begin paying off. Okay, so the production phase generally divided in three phases: build up or ramp up, okay, and then plateaued, and then decline. Okay, so that's happened in most of the production cases. So this is the case. Decommissioning. So when the field passes beyond a point where it can produce a profitable amount of oil and gas, remember the word profitable amount, okay, because there might be some trace amount of oil and gas is in there, but it's not profitable at all. Okay, so at that point, if the operating cost become more or like higher, okay, then the profit, at that point we actually start the oil and gas being decommissioned. So sometimes this means completely removing all related infrastructure, and the other times it means like leaving some equipment in place so that if we can find other oils, if we have planned to drill any other oils, we can utilize that, or we can redevelop the oil again if the financial situation change or new technologies became available. One of the example would be like the tar sand. Okay, so now we have the new technologies like SAG-D. So that's actually give a whole new idea of like extracting the oil and gas from the bottom. Now before the older technologies we used, we can extract a lot less than right now what we are doing in a very very good environmental way. Okay, so that means like the new technology becomes available, and then we can actually get more oil and gas, right? So more resources. So that is the thing. Decommissioning has become a very important topic recently due to the higher level of scrutiny of the environmental impacts of improperly contained decommissioned oil and gas. Is very important, and that's exactly why I'm saying like SAG-D is very important, because SAG-D get the least environmental effect, as you can if you have seen their operation in oil sands. Okay, so that's why decommissioning is very very important. Now let's talk about our main topic, which is the field appraisal. Okay, so field appraisal. So what is the objective of the field appraisal? Well, we already know the objective, we have discussed. So the objective of performing field appraisal activities on the reservoir is to reduce the uncertainty in the description of hydrocarbon reservoir, to provide more valid and more solid information with which to take more, the perfect decision to the next action. Okay, information is power, and the information will help to reduce the uncertainty, and reducing the uncertainty will make your logic more clear to make the decision for the next and right decision. Okay, so that's why we do the field appraisal. Now, as we have discussed before, like what would be the next action of the appraisal? The next action could be undertake more appraisal, yellow lights, remember, or to commence the development, green light, or to stop the activities or sell the prospect, red light. So in either cases, like the field appraisal activity should lead a decision which yields greater value than the outcome of the decision made in absence of the information from the appraisal. What does that mean? This is a very, very important part, and this gives a whole idea. Like, I mean, should we continue doing the appraisal or should we skip the appraisal? Okay, we'll actually learn a little bit more about this. Okay, about this line, we'll actually learn a little bit more. Okay, so the objective of appraisal activity is not necessarily to prove you have more hydrocarbons or not. It will give you more confident that what size or how much would you actually invest. Okay, for instance, it could actually give you more idea on like I mean better idea on like I mean yes, you have more hydrocarbon, but the main point of the appraisal is to give you the perfect idea of like how much really it got, so that I invest. I don't want to invest more or I don't want to invest less. I want to invest what I actually have to invest to make the profit. Okay, that means, for example, the appraisal activity which determines that a discovery is non-commercial and should be considered worthwhile, since it saves financial loss which would have been incurred if development had taken place without appraisal. Okay, so that is the thing. Now, if you think the appraisal cost is higher, in that case, you may not continue doing the appraisal. So right after the exploration, you can directly start drilling. If you think like that drilling cost, or like I mean, sorry, start developing. If you think like the development cost is cheaper, you don't need to do the appraisal at that point. When that kind of situation would arise, for instance, just give you an example. Here is the land, and you have one reservoir in here. Okay, and you know, like I mean, you have extracted oils from here. Now you already have the existing facility in here. Okay, now well, your geologists said like, well, we did some exploration that the other parts near the neighbor, like I mean within 1 kilometer, we have seen like there is another prospect. So would you mind to look at that? Now, well, if you do the appraisal for these prospects, so probably it will take 5 million more. I mean, $5 million to invest more. So, would you actually continue investing $5 million to get a proper idea how much oil and gas we have, or would you just start? I mean, developing like a wildcat because you already have a present infrastructure nearby. So, what you will do in that case? Probably, I mean, you will do the cost benefit analysis, of course, but if you do the cost benefit analysis and if it shows like without doing appraisal, because appraisal also takes some time value of money. Okay, so you don't want to lose the money also. So you think like, okay, so if I start doing the development right now, I would, number one, save money, and also I would save time. So let's not doing the appraisal, let's continue drilling and getting that. So you can do that without appraisal. Okay, so this is the case. But if you want to do the appraisal, then what it is, go to the next slide. Okay, so the money or like the investment you do for the appraisal should not yield the greater value than the outcome of the decision made in absence of that information. Okay, we'll see again. What is that? Now, this section will consider the role of the appraisal in the field life cycle as the main source of uncertainty. So what we need to do? We need to reduce the uncertainty. How we actually reduce the uncertainty? Okay, so you know all the previous lecture we already know. Okay, what is the STOIIP, right? We already know that, and we have now better idea. So stock tank pool initially in place, so that means like you have like how much or actually you have inside the reservoir, or this for the oil or this for the gas, okay, initially in place. So that means if this is the reservoir, you got the gas, you got oil and water. So here the gas, how much gas you might have, how much oil you might have. So that is the formula for the estimation. Now the more close estimation you have, the better understanding, the better you'll make the decision. Okay, so the appraisal activity actually use these formulas and all other tools and methods to try to quantify how much actually it really got. Okay, so appraisal activity, if performed, is a step in the field life cycle between the discovery of the hydrocarbon and the development. And as I said, the role of appraisal is to provide cost-effective information, which is a subsequent decision can be made. That means cost-effective in this case means the value of the decision with the appraisal information is greater than the value of the decision made without the information. That means your appraisal information's value should worth more. How would you determine that before even doing the appraisal? Well, we'll see an example at the end of our slides. A very important example. That's how you would actually determine the probability of, should you actually continue doing the appraisal or not. So to do that, to know the cost effectiveness of the information of the appraisal, like should you actually continue doing the appraisal or not, there are some things you need to know about the petroleum economics part, and which is the net present value. So what is the net present value, or NPV? So the net present value is a future amount of money that has been discounted to reflect its current value as if it exists today, okay? So the concept of the NPV, or net present value, is important because when considering whether undertake the further appraisal activities, we are comparing future profits to current baselines, or the current or near future expenditure. That means current expenditure actually, okay? So the NPV, or the net present values, is always less or equal than the future values, mostly always less, okay? In rare cases it's future value, it's equal if it's a very short span of timeline, or if the economy is really stable, but it's not. Because the money has interest earning potential. So what is actually the NPV? Let me give you a short example. What is the NPV? For instance, you have $100 right now in your pocket. Okay, if you would invest this $100, after 5 years, it could be $200, right? If for a certain portion of interest, if you actually put in a saving account, for instance, your bank, or if you invest in a share market or anything. So whatever it is, your $100, if you invest it, it will become $200. So what does that mean? That means these $200, this is the future value, okay? So these $200 actually worth $100 right now, or it's present value, okay? So that means if you do any activities, and if you think okay, in future, this is a time equal to 0, that means right now, t equal to 0 right now, and this is t equal to 25 years. Remember that previous example, okay? So if you think okay, you have invested the money and then you got the return a little bit, so here, so after 25 years later, you get, for instance, 40 million of $40 million. Okay, $40 million. So how much it actually worth right now, because that's after 25 years later, $40 million, not right now. So there's a discount factor, or sometimes you can also call it, like, I mean, in banks actually they call it interest, rate of interest. Okay, we call it in this case a discount factor. So based on this discount factor, if you calculate based on this, depending on what is the discount factor and how much is the timeline, okay, timeline T. So based on all these factors, probably this $40 million right now, it worth like $30 million. Okay, so this is the present value. Okay, and what is the NPV? The net present value. So probably you have invested a lot in it. So what is the cumulative value? So you will calculate net future value at first, and then you got the net present value, or directly you can actually calculate like the net present value at t equal to 0. So this is the concept of NPV, or net present value, and how we can actually calculate that. So net present value, or the present value, PV, equal to cash flow divided by 1 plus interest to the power of year. Okay, so this is how we calculate the NPV. Okay, this is how we calculate the PV, and the summary summation of all the PVs are the NPV. Okay, so this is an example how this works. For instance, at year 1 you have invested money, so after 1 year later it became $10 million, but right now its worth is 9 point something. Okay, after like the second year you will invest $5 million, but right now this $5 million is $4 million. Blah 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 blah. So for instance, after 8 years later you will earn $10 million, for instance. Okay, but right now its worth is $4.6 million. So if it's a 10 years long project, add like to the summary, and then you'll find the NPV. Okay, and here the project 2, similar fashion, you actually move and calculate the NPV. So which one is bigger? Project 1, the NPV is positive and bigger than the project 2. Project 2, the NPV is less. That means what? That gives us a decision making tool. That gives us the idea that the project 1 is viable. That means if I actually run the project, after 10 years later, we'll get lots of profit, so much that it will give us $7.7 million, for instance, return back. But if I go for the project 2, then I will lose $6.5 million. So definitely I will choose the project 1 if I have the alternatives, right? So this is how the NPV works. Okay, clear? Field appraisal. Remember, if the appraisal activity does not add more value than its cost, then it's not worth doing. Okay, let's see an example how the appraisal activity works. Okay, so this is decision making tool. So for instance, here this decision you actually stuck in here, so you do the exploration in here. Okay, and then you will do the your next phase is the development. Now, would you like to do the field appraisal or not? You ask the quotation, for instance, the appraisal activities quotation, and the company, or like the geologist who are actually working for you, they gave like, okay, so it will cost $1 for the appraisal. Okay, so that means this is the cost of the appraisal. Now this is the for instance, like if you go in this path, the net present value, the profit is D1 if you do not do the appraisal, and if you do the appraisal, the profit would be D2. Okay, so the profit at the NPV, net present value, would be D2, but you have to deduce, you have to subtract the appraisal cost because you did yes. So the net profit would be D2 minus A. Now, if this net profit D2 minus A is bigger than D1, we will do the appraisal. That means if 2 minus A is bigger than D1, or we can say another thing. We can say if D2 minus D1 is bigger than A, right? That means if the difference between these D2 and D1 here is bigger than the appraisal cost, that means if appraisal is cheaper and cost benefit, only at that point we'll do the field appraisal. And the baseline is always, remember, what is that? NPV. Okay, where is that? Yeah, the net present value. Okay, remember that. So this is everything what I actually say the side. Okay, so the cost of the appraisal must be less than the improvement in the value of the development which it provides. Okay, all right. So these are all like the ideas, like what are the how we can actually identify and quantify the source of uncertainty, and what are the source of uncertainty. For instance, what would be the source of uncertainty in a reservoir? For instance, like the rock volume, we didn't estimate the rock volume beforehand in a good way, so we have a gray area in there. Or like the porosity, the previously assumed porosity is not the same. We have, it is more porous right now, as we have indicated. It has indicated in new data. So that means we can actually extract even more. Okay, or like the hydrocarbon saturation, or like the for reservoir formation factor, or even like the recovery factor. There are many uncertainties could have in the reservoir, right? So the objective of the appraisal is to reduce this uncertainty, and by using this information we would put it in this formula. Where is that formula? Here. And then we'll develop something like that. Okay, and then we'll get our idea, should we actually continue doing the appraisal or not. So what are the tools we actually use to detect this, to reduce the uncertainties? We use rigorous seismic survey, or 3D seismic surveys, or if we had 2D, then we should actually do the 3D seismic survey. Or if we already have the 3D seismic survey, then we should actually analyze that data even more rigorously, or reprocessing like the old images using gathering the Landsat data, or even we can actually take a help of artificial intelligence to get like the accurate information on that. Okay, and we can also what we can do, we can gather the source of uncertainties, for instance, like the wireline logs, and analyze the more data and other tools. Okay, so this is how we can actually reduce the uncertainty using these tools. Okay, to do the appraisal. Now, how we actually express uncertainty? So the way we express uncertainty in HCIIP, or like the ultimate recovery, is used. We actually use the curve, right? To reduce uncertainty is the high minus low divided by 2 times of median times 100. Okay, this is the mathematical representation of the uncertainty in a parameter we actually express. Example like this, as you can see here, it's a low case. For instance, you actually did the oil in here, so this is the oil water contact, and you get in here, this is the low case. As you can see in this picture, it could be the medium, but if it's like the more, then we get the high case. Okay, so that's how we can actually this is just an example how possibly the it actually works. So here is the cumulative probability function versus the stock tank oil initially in place, the curve. So the curve more steeper, that means there is a more probability of getting the dry oil, and more round will get more oil bearing probabilities. Okay, cost benefit calculation, the most important part of this field appraisal. Okay, so for instance, from these curves, while analyzing the appraisal tools, analyzing the data, we have the informations on the appraisal. And now what? Now we should actually make decision whether we'll do the appraisal or not. And how we do that? The value of information from appraisal equal to the outcome of the decision with the information minus outcome of the decision without information. Remember? All right. So if you remember that, in that case, we'll actually continue on an example, a very important example. Okay. So what we'll do, we'll actually determine in a real case scenario, like whether we should actually continue or carry on with production or not. So in that case, we have three choices. Okay, so for instance, we have a reserve, a natural oil and gas reserve, and we have a range of uncertainty. What are the ranges? We have the range of uncertainty, like the low, medium, and high value. Remember this uncertainty, low, medium, and high. So the low, medium, and high value of the uncertainty are, like in that reservoir, there could be possibly 20 billion standard tank barrel of oil could be deposited, or there could be 48, most likely. What is the probability of that, getting that? We can actually calculate the uncertainty. And there could be 100 billions of standard tank barrel. So these are the values we have. So it could be kind of like a nearly like 20 could be the dry well, ish, but still 20. If we have like medium, that 48, or like 100. So one can perform the appraisal, which determines which of these three cases is actually true, and then tailor a development plan. So what is that? For 20 million barrel, or for like 20, we will not invest more money for the operation purpose, or like development purpose. Okay, now how much money we maximum can put for the development purpose? Should be less than 20, of course, right? Or the cheaper the better. But what if it got 48 billion barrel? So if you actually design a smaller facility, but all of a sudden you got 48 billions of barrel, then the whole facility would be undersized, and you have to open another facility, and that would even cost even more. Okay, or even worse, you have designed the facility for 20 but you got 100. That's even worse. So what we can actually do in that case? Should we actually do more appraisal, or we'll just start developing? What should actually we do? And if we want to do the appraisal, then how much money maximum we should actually invest for the appraisal? Let's see that. So before starting the cost benefit calculation of the given problem, okay, we'll actually talk about like how we actually do the problem solving. So there are two types of nodes in this decision tree. We'll actually develop a decision tree. One, this one, the rectangular one, is the decision making node. That means there will be one input and two output, and the two output would be yes or no. All right, the branch of set of possible actions. So this is the decision making nodes, and there is a chance node, and the chance node would be like there is an input and there will be a couple of outputs, I mean several outputs actually, and the chances would be based on the probability. And what are the chances gives? Chances give the possible results or the situation. That means it will give us the results. So decision making is based on the action, and chance node will give us the result. Okay, so decision making tree and the chance tree. So decision making trees can be considered as the roadmap which indicates the chronological order in which a series of actions can be performed and show several possible courses. Okay, only one which will actually be followed. So the tree can be drawn, and the first decision can be taken and asking which actions are possible. Then we would actually consider all the possible. Okay, and it would be followed by considering the future action which will actually take the, as I said, like the tree, it constructed chronological order from the left to right. Okay, then the value of the leaves are taken place in the diagram, starting the far most future and the right side, and values represent NPV of the high cash flow with corresponding and individual leaves. So we'll actually see that how we'll actually solve the problem. Okay, let's see. So here is the cost benefit calculation problem. Okay, now here is the decision. We do the exploration okay, and then we have three different scenarios. We have low, which is 20, we have medium value, which is 48, we have high, which is 100. All right, now the question is, should we do the appraisal to do the development or not? Let's calculate. So these are the probabilities we have, and the probabilities are equal. Okay, so if there is an equal probability, that means we have 33% chance of having low, 33% chance, actually 33.33, something like that, but and there is a 33% chance of getting the higher one. All right, so let's do the calculation. Now the first step, appraise. Should we do or shouldn't we do? Now if we do not want to do the appraisal, no, then what we'll do, we'll start doing the development phase. Okay, now here is the two decisions. Should we do the development or not? If we do not do the development, in that case, what we can actually do? We can sell the prospect. or abandon. All right. If we decide to do the development, in that case, we have three different scenarios. Number one, 20 billions of billions of barrel. Number two, 48, and number three, 100. Now imagine you will make you will actually make the infrastructure based on like the medium. Okay, based on the medium, you make the infrastructure based on the medium. That means if you actually base the if you do not do the appraisal, that means you do not know actually how much it contains, but you have already invested on the infrastructure and you have found only 20, then the infrastructure would be bigger. That means you lose money, a big chunk of money that there is a probability or possibility that you are going to lose. Now, if the infrastructure is like that, you already have invested such money for the infrastructure, okay, and it will actually give only $6 million profit, okay. Now we can say, well, it's the infrastructure is slightly oversized, but still we just got the money, and you will just take the money and like you can't do anything more. However, there is another 33% chance that you might, with the same infrastructure, you might get 100 million barrel and get more profit, like 40. Okay, so for instance, here you made the infrastructure for like to handle the oil capacity of like 50 million barrel. Okay, like that. So that's why it's still like it can process like the 40 million barrel, but you can make more profit. But in this case, you have earned a lot of profit in here. Okay, now what's about like do the appraisal? If you do the appraisal, then there are three different choices again. One, there is a 33% chance that you got $20 million. There is a 30% chance, 48. There is a 30% chance, 100. Now in this case, there is an interesting thing. That is, if you do the appraisal, then in this case, what you have like a freedom of should we continue doing that or should we not. If you don't continue the development, it will be 0. That means no. But if you actually continue doing, that means you will have a big loss. That means that means no. But if you actually continue with that, that means you will have a big loss. Okay, NPV is minus, and what we have learned from the negative NPV, that means you will have a loss in the project. Same like that. Okay, NPV is loss. Okay, now in this case, what would be your decision? Your decision would be not going for the development. Okay, you have invested money for the appraisal, you just lost some money for the appraisal, and you're fine with that. I just don't want to go for the investment because it would be a financial disaster. Now, if the oil actually got like 33%, if you actually got 48 billion, and during the time of development, you have a decision like should you actually go with that or not. Then you have done the analysis and find like, okay, if you continue do so, you'll earn $6 million, just exactly like that. Okay, so it is like going in a calculative decision making order, and this happened by random chance. Okay, you don't have any control over the chances, but here you have control over the decision. So should you go or not? Well, since this is a positive value, so there would be a profit, so we will go with that. Now let's come with a big number. There is also another 30% chance of 100 million barrel. You do the appraisal, and then you find, like, at the development phase, okay, yeah, it seems like you get the 100. So if we actually continue, we'll get a profit of $66 million. But here it is no, so definitely we will continue. Okay, so here you have a chance of you have a hint of taking, more better decision than going without appraisal. Now these are like just estimation, but really how would we actually make the decision, like should we actually continue or not? So let's see how we can actually do that. So in that case, what do we know about the appraisal? We know the value of the appraisal information is equal to value of total outcome with appraisal information minus the value of outcome without appraisal information. That means the value of with appraisal information. What are the values? We have 0 in here, 0, plus we have 6 in here, plus we have 66 in here. That means total is 6 plus 66 would be 72, I think. And what would be the value of without appraisal? We don't have any other choice, so these are the values. Okay, so what are these? These would be minus 40 plus 6 plus 40. That means 6. Well, wait. 40. Just 1 second. Oh yeah, sure. So yeah, so total 72, and there are 3 outcomes by 3 by 3. Okay, so we got, here is the solution actually. So we got $24 million from doing the appraisal, and we got $2 million on not doing the appraisal. Okay, so what is the cost of the appraisal? The cost of the appraisal would be $22 million. You remember this, minus this value minus this value. That means we'll get $22 million. That is the value for the appraisal, or that is A. Okay, so A is 22 millions of dollars. That means if the prospect is more than is the profit is more than $22 million, we'll do the appraisal. If the profit is less than $22 million in our calculation, we'll not continue of doing the appraisal, because the appraisal cost is $22 million, right? So for instance, if it's this scenario, or if it's this scenario, we'll definitely continue doing the appraisal. If it's these two scenario, not, and of course not like this negative scenario, we'll not even continue doing the project at all. So that is how we actually calculate the appraisal. Okay, how we actually justify on investing $22 million to determine the appraisal. All right, so this is how we actually do the cost benefit calculation for the appraisal. So this would be all for today's lecture, and now you know how to do the appraisal, and this is very important part of our whole field life cycle. So I would actually suggest you to go with it very carefully, go with all the problems very carefully, so that you can actually learn on how to make the decisions. And if you have any question on this lecture so far, please let me know, and please ask any type of the question if you have any confusion. So good luck everyone, and have a good day. Take care. Bye.